Okay, so today we are finding domain using graphs. Okay, everybody, you ready?
Yeah.
All right. So let's read together. The domain will be all of the x values on the x-axis that the graph takes on or covers. Simply move from left to right along the graph and note which values of x are covered and which are not. All covered values of x are in the domain. The range will be all of your y-axis that the graph takes on or covers. Simply move from bottom to top along the graph and note which values of y are covered and which are not. All covered values of y are in the range. Okay, so take a look at the graph. I'm going to zoom in a little bit here. So you'll notice this graph, it has a definite starting point here, right? That's solid. We're going to go around, and then this arrow indicates that this graph is just going to keep going on forever. All right, so if we're talking about domain, does the graph exist over here where my pencil is? No, there's no graph here. It doesn't start until x is equal to -4. So if I'm looking at my x-axis, the first time my graph even appears is at -4. And then I have values all along the graph that will continue on forever, won't they? If this line just keeps going, every value of x that is greater than -4 will be represented in my graph at some point. Greater than -4, right? This, when it trails off like this, right? This is just going to keep going this way forever. It's never going to turn around and come back. It's not going to, suddenly make a U-turn somewhere. It's going off to infinity. So my graph doesn't even exist over here. It doesn't start until -4. So that is why we would say that our domain covers all x values that are greater than or equal to -4. So see how we have this written here? X is greater than or equal to -4. There's our domain. Does that make sense so far? Okay, let's check out the range. So as far as the range is concerned, the graph doesn't exist down here, nor will it ever. No part of the graph is ever going to be down here. So it looks like I'm not even starting. I think this was supposed to kind of hit more nicely right there. So my graph doesn't even start until I hit -1. As I continue up, I do have values that basically go on forever, but I don't have anything that's less than -1. So that is why we say the range would be all the y values that are greater than or equal to -1. So far, so good? Okay, flip.
This isn't like test. If it's like not exactly on the line, I just
Yes, but I think if you're ever in doubt, just ask me, but I would say yes yeah. All right, so cover up the domain and range, pretend you don't see it. Now, see how this graph, it doesn't have arrows on the end, but it goes to the very edge of the graph. Whenever that happens, you are allowed to assume that it just continues on forever. So even if you don't see arrows, if it really does go to the very end of the graph, you'll notice back on this, I'm just going to flip back for 1 second. This one did not do that. There was a clear stopping point. It didn't go all the way to the edge of the graph. If it did, I could have assumed that it was going to keep going. All right. So when it is drawn like this to the very edge, even if it doesn't have arrows, you can assume that those arrows are there and it's just going to keep going forever. All right. So pretend you don't see the domain. Now, I know it appears to you that the graph doesn't exist right here, but doesn't it? Is there a value for this graph when x is -6, let's say? So all the way over here, is there a value for x? Yes, it's just not shown here because this is going to keep going up and out forever. Same on this side. So there will eventually be, when x is -6, there will be a y value that coordinates with that. You follow me? It'll eventually get there. What about -100? Will there be a value on the graph? Yes, because this is going to keep going in the negative infinity direction forever. Every value will eventually get covered in the negative direction. How about in the positive direction? There's no value at 4, but couldn't you, if I could zoom out on this graph and keep zooming out, wouldn't I eventually have a value at 4? I would. So are there any values of X that I won't have value for? No. That is why our domain, do you know what this notation means? Braylon, tell me.
Wait, which one?
This right here. What does that mean?
What?
X, funny looking ER. Evan?
The domain of X includes all the numbers.
Yes, that's basically what this is. That funny looking E stands for is an element of. So it's saying X is an element of, or is included in, or includes all real numbers. So when I want to tell you that X, my domain, includes all real numbers, that's the notation that you're going to see. X, I think that's called an epsilon. Is that right? Is it epsilon? Am I know? I think it's an epsilon. I'm not totally sure. I don't know. I'll double check. But yeah, it's that funny looking E and then the R symbol for all real numbers. Now let's talk range. So pretend you don't see the answer there. The range. My graph does not exist down here. And I want to ask myself, will it ever get there? No, because they are going to go on forever, but they're going up and out, up and out. It's never coming back down here. It's never coming back. So the graph will never exist down here. It starts existing in the Y's at 0, doesn't it? Will I have every Y value represented as I go further and further in the positive infinite direction? Yes. So I'm going to have everything that's 0 or greater. Does that make sense? So that's why our range would be Y is greater than or equal to 0. Cover up domain and range on the bottom. Pretend you don't see it. See if you can figure it out. So this one, let's just talk about the graph for 1 second. This one has a definite starting point. It's starting right here. It didn't continue off to the edge of my graph, so there's its starting point. This side, it does go all the way, so I can assume that that's just going to go off forever. So, oh, shoot. I know you're not looking, but there we go. So go ahead, see if you can determine the domain and range. I know you see it, but do you see why it is what it is? Yeah, you're with me? Okay. So domain has got to be X is greater than or equal to 0. I have no domain over here. I have no graph on this side in the negatives. It doesn't exist here. It starts existing here at 0, and then it will continue forever. So all of these numbers are going to get represented from 0 on. I do the same thing with the Y's. There's no graph down here, nor will there ever be. It doesn't start until here. But will I have all the Y's represented in the positive direction forever? Yes, because this is going to keep going up forever, just slowly, but it'll eventually get there. So that is why our domain and range are as follows. How are we feeling so far? Everybody's okay? I'm not okay because I hear noise. DJ. He doesn't even know. I hear it. What? Oi. Okay. I mentioned a new interval notation. Take a look here. Let's see if we can figure this out. First of all, let me move this mouse out of the way because it's annoying. There we go. Yes. Oh my gosh. So fast.
Run.
All right, so let's take a look at this interval notation. What is going on here? What does this even mean? So instead of writing X is greater than 5, here's what we can do. We can put an open parenthesis, a curved parenthesis here, 5, comma, infinity, close my parenthesis. What does all this mean? I'm confused. Well, take a look at the difference between this one and this one. Notice that I'm either using a smooth parenthesis or a bracket. What's the difference between these two? Yes.
Does that represent the greater than or equal to?
Yes. So if I have a greater than or equal to, I'm going to use the bracket. So this, what this looks like on my graph is that that point is included. It's like a hard stop. I'm including that point. This point itself is included. Oops. Is included. So if I want to say X is greater than 5, I don't include 5 itself, right? So that's how I represent it in interval notation. I use the curved parenthesis. So 5 itself is not included. This point is not included. Okay, so this basically tells you this is where you start and this is where you're going off to. So if I want all the x's greater than 5, I'm starting at 5 and then I'm going to go off to infinity. Here again, I'm starting at 5, I'm going to go off to infinity. What if I wanted to show less than? So on the other side, you'll see I have x is less than -3. So I'm not starting at -3. I started at negative infinity and I'm going to come up to -3. -3 is going to be the highest that I get. So we're going to start at negative infinity and I'm going to end up at -3. You'll notice again, I'm using the smooth parentheses because I don't have that or equal to. Okay, so I guess in these, your first number or whatever it goes in here, comma here, you're going to have where you start. Starting point, and then here is where you finish. And then your parentheses are either going to be curved or bracket. Use curve or bracket, depending on if you have the or equal to or not. Let's take a look at some of these. So what if I have a graph that only exists between -2 and 4? I have numbers that are greater than -2, but I don't include -2 itself, and I go up to 4. Well, the first number is where I'm starting. As I'm going from left to right, the smallest I have is -2, and then I'm going to end up at +4. Notice the curve and then the bracket, depending on if I have the or equal to bar or not. So cover this up, try and rewrite the this one without seeing the answer there. What would that look like? Hello.
Sorry about that.
No, it's okay. I had no idea until I got this email. I'm like, oh, great.
That's all we have, so we'll still have more.
All right.
But we've been trying, it's getting them back.
I know.
It's my
Well,
favorite class.
I know.
Interval notation.
So far, so good.
Yeah.
See ya. Okay. Did you get an answer? Did you write that? Bracket with a 5 and then a smooth curve with a 7. Do the same thing with the in between 1 and 6. What would that look like? And then I'm going to give you a new one to try. Did you write it in interval notation? Evan, what do you write?
I got parentheses -3, 10 parentheses.
Perfect. Is this okay? Have any of you done interval notation before? You have? Okay. Has anyone never done interval notation before? Okay. All right, let's look at the bottom. What in the world is going on with this thing? Okay, so we have this random graph, right? You'll notice that it exists in some parts, but then it's missing in others. So I do have a graph here in between, what is this? X is -4 to X is -2, but I actually don't have a value at -2 itself, do I? See how it's an open circle there? That means I don't have a value right there. I have everything up to it, but I don't actually have a value at -2. Then I don't have anything at all in between -2 and 0. There's nothing in the X on my X-axis, that's fine. But then it picks up again. I have values in between 0 and 2, nothing in between 2 and 3, but then it picks up again from 3 to 5, but I don't have a value for 5 itself. So if I were going to write the domain of this, we always start from left to right. And then when I'm doing the range, I start from the bottom to the top, right? So if I start at the left, I don't have anything until I hit -4. So you'll see they put a -4. Okay, that's where it starts. And then I go up to -2, but I don't include it. So see how this one had the or equal to, but this one does not. That's a big deal, because I don't actually have a value at -2 itself. So that this chunk right here represents this piece of the graph. Then my next part of the domain goes from 0 all the way up to 2 on the x-axis, right? 0 to 2 are covered. There they are. Lines underneath, because I do have solid dots at both. So I do have a value at 0 and I do have a value at 2. And then the last piece between 3 and 5, but I don't include the 5 because I don't have a value there. So what I would like you to do is now turn this into interval notation. So go ahead and write right next to it. See if you can turn those 3 pieces into interval notation. Okay. You got something? So just for this chunk, how do you rewrite that in interval notation? Jake, go ahead.
Bracket. -4. -2 and then a parenthesis.
Perfect. So double check that that's what you have for the first chunk. Middle chunk. Someone give me the middle chunk. Mackenzie, go ahead. Perfect. And the third chunk. Braylon, go ahead.
Bracket 3, 5.
Yes. Now, when I go to list the domain, since it has these pieces, here's how we're normally going to write it in interval notation. So we are going to say that our domain is represented as follows. -4 to -2, and then we put a U in between them. Do you know what the U stands for? Anybody know? It stands for union. So it means it's all these pieces together. So if you put them all together, that would represent the entire domain. So that weird looking U shape, I don't know the name of that thing either, to be honest with you. And then you could do the same thing for your range. So notice this range, here's a good thing I'm glad that this question has, that they've asked it or that they set it up this way. So take a look at the range. It doesn't exist down here at all, right? Nothing's happening here. Yeah. Okay. My graph doesn't even start until y is equal to +1. Now let me ask you this. I have values when y is equal to 2. Now look at when y is equal to 3. I have 2 open dots, but I have a closed dot. So do I include 3 or do I not include 3 in my range? What do you think? Would 3 be included or not? There's 2 open dots and 1 closed. What does that mean? Prince? Yes. If there's any point on the graph, it doesn't matter. All I need is 1. So I do have a closed dot at 3. If that had also been open, I wouldn't have included 3. I would have just gone up to it. But since I do have at least 1 solid point there, it goes all the way up to 3. So if you take a look at how they have the range set up, there it is between 1 and 3. So go ahead and rewrite that using that interval notation. I'll give you just a second and we'll see if we all match. Did you write this? With brackets on both? Perfect. Okay, let's see what's next. So check out this graph. My gosh. Okay. Imagine I didn't know the answer. Maybe I should make a version that like doesn't have the answers just spelled out for you. Let's just look at this graph and let's see if we can kind of talk about the domain. So you can see my graph just goes to the end. So I can assume that these are arrows that they just keep going forever. All right, cool. So looks like I'm starting at -infinity. I have values, I have values, I have values, I have values. Now I hit this open circle. However, I have a closed circle right above it. So I ask you, does this graph exist when x equals -1? Yeah, it exists right here. So I don't have to represent a gap there. There is no gap. There's no gap in my x coordinates, right? I have all of these x's represented, and then I do have this x represented too. It just jumps up here. So then I'm going to continue on. Oh, I reach another hole, except there's a dot there. And then as I continue, look, there really is actually no gap at all as you move from left to right. There's a place for you to go. You follow me? Okay. So what does that mean in terms of my domain? It means I can plug in whatever I want. The domain is all real numbers. I have everything represented here. There were no gaps. This graph exists over the entire coordinate plane along the x-axis. Does that make sense? Yeah, okay. Range, let's see. Well, if I start at the bottom and go to the top, this is going to continue on forever, going down. So I know I'll have from -infinity coming up. Okay, so now I do reach a hole, but if you look right here, I can just keep continuing on my path. Right? Even though there's a hole there, if I just come over here, I can still continue my way up if I wanted. So was there ever a y value that wasn't represented? Your silence, I'm sure, means no, there are no gaps as you are going from the bottom to the top of this graph. Every single y value is represented somewhere on the graph. Sometimes more than once, right? Y equals 1, for example, is represented twice, once here and once here. Doesn't matter. I need every value on my y-axis to be represented at least once. If it's more than once, okay, fine. I just can't have any holes, but I don't have any holes. You see that? There's no holes in this graph. As you go from the bottom to the top, there's ways to trace your way all the way along. And that just goes off to +infinity. So that is why the range would be all reals. Now, how do you turn this into interval notation? What does that look like? Thoughts? Braylon, you got one?
Would it be? Wait, of which one?
This one. How do you turn that into interval notation?
I-
Jake, what would you do?
The parenthesis infinity to negative infinity to infinity. And then be concerned by two parentheses.
When we're going to infinity or negative infinity, we always do the smooth parenthesis. We don't do a hard parenthesis because infinity keeps going, right? So there is no hard stop. So we use the smooth parenthesis, but that's how it's represented. That's it. Because think about it, I'm going from negative infinity, right? I can go off forever in that direction, and I can go forever in positive infinity direction. So I have no gaps there. So the same thing for the range. Easy peasy. Now that I know that that's what I'm doing. Yeah.
I really like
Go so fast. Oh my gosh.
Run. Great, makes you run.
it. Oh, you didn't run.
Yes, I did, I squinted.
Okay. Don't look at the domain and range for the bottom one. Let's see if we can do this one together without looking over there. Okay, so I noticed that my graph is coming to the very edge of the graph. So I can assume that that goes off forever, that goes off forever. Okay, cool. So let's see. I'm starting at negative infinity. I have values there. We're doing the X, we're doing the domain first. So as I'm moving from left to right, I have values, I have values, I have values. I hit this. I have an open dot there, but that's okay. I have a closed dot there. So as I continue my way across, there was no gap there. I know I jumped from here down to here, but it doesn't matter. I'm talking about a gap moving horizontally. There is no gap. I move straight on and I just keep right on going. So as far as my domain is concerned, I don't have a gap yet. Let's see, keep going, keep going, keep going, keep going, keep going, keep going. Oop, okay, I have a closed dot here and an open dot here, but that's fine. I'm just going to jump up to this one. There's still no hole there, but I do have a value at 2. But look at this. Keep going, keep going, keep going, keep going. I have a hole at 4. There is no value for me to jump to. There's not a closed dot anywhere. There's no other piece of the graph happening at 4. So this graph exists, the domain from negative infinity. I had no gaps until I hit positive 4. Do you see that? Once I hit positive 4 though, anything past that I have, right? Once I get past over this hurdle, now this is going to go on forever and all of my values for to positive infinity will be represented there. But I have to show basically that there was a break at positive 4. How do I do that? Well, I came from negative infinity all the way up to 4. Do I include 4 itself? No, because there's a hole there. So if you take a look at what we have written for the domain, I'm starting at negative infinity and I go up to 4. I use the open parenthesis because I'm not including 4 itself. And then for the other piece, because I got to jump over that hole, I'm going to start at 4 and go off to positive infinity. Does that make sense? All right, you say this now, but we'll see in a few minutes when I have you trying it on your own, I hope. Let's try the range. Okay, pretend you don't see it. All right, range. Start at the bottom. This, remember, is going to keep going forever. So I have from negative infinity, and I'm going to try and make my way up. Oh, I reached a hole, but I can continue my graph over here if I wanted. So I can continue, continue, continue. I'm out over here, but I can jump back. Like, oh, I thought you told me. I don't ever get past positive 6 though. You guys see that? I start at the bottom, and although there are some open holes, I'm trying to move vertically. So as long as there's somewhere else that I can jump to and continue my trek up the y-axis, it's fine. There's not actually a jump there or a gap. So I have values for negative infinity all the way up to, even this one at 2, I do have a value for 2. I just jump over here. I can get up to a little bit over 5, but then I can just jump here. The highest I'm ever going to get to, though, is 6. Is there any part of this graph that has a y value of 7 or 8 or 9? No, it's never going to get there. So what does that mean for my range? I'm coming from negative infinity, and I have values all the way up until positive 6. But that's where it stops for me. That's it. I can't go any further than that. So that's what it looks like. Oops, a little too high. Now, why is it a closed bracket right here? Because I do have a value for 6. It's closed there. There's no open hole. I have a value at 6. So I would use that bracket. How are we feeling? Okay. I think so. Why don't you try? No, that's not what I want. I mean, I guess just look at the last 2 and see if you understand why it is what it is while I hand out to you your homework. I have 2 sheets. I'm deciding which one. I think I'm going to do this one. Yeah, let's do this one. Yeah. Yes. All right, I think I am done with the video, so I'll stop that. Oh gosh, tell me I never hit record. Shoot. I might have it from last year. I don't know. Oh, that's so frustrating.